In this problem, we are given a circuit diagram here. We are asked to use the mesh current method to find the power absorbed or delivered by the 80 volt source to the circuit shown, and find the power absorbed or delivered in the 8 ohm resistor. So when we're using the mesh current method, we're going to break our circuit into parts. So we have this part, we have this part, and we have this part. This is for Kirchhoff's voltage law. It kind of makes sense because you want every part set equal to 0 because we're looking at the voltage over a closed circuit. Now we need to find the current flowing through here for each individual part. So I'm going to draw the currents. And they're going to look like this. We could draw them going the other way, however our equations would be backwards, but we would get the same answer, so it's not really a big deal. I just like to draw my equations going like this. We also have a voltage here, along with our resistance, and we know our voltage goes into the positive, out of the negative, so it's going to look like this. Now we can start first by getting the first equation. So we're going to look at this first part right here. We have the voltage, which is at 80 volts, in opposition with our current flow. So it's going to be a negative. We're going to have a negative 80 volt resistor. Then we're going to have a plus, and then we're going to add all of our resistors together because they're in series for this particular part. So we're going to have a plus 31 ohms, and this is for I1. This is next to our I3, and this is next to our I2. So we have to subtract this because they're going in opposite directions. Our I1 is going this way, while our I3 is going this way. Same thing for our I2, it's going this way, and our I1 is going this way. So we need to compensate for that. We're going to have a minus 5 ohms, and this is for our I3. And then we're also going to have a minus 26 ohms, and this is for our I2, and this is equal to 0. Now we can look at the second equation. I'm going to do I2 in red. We just have resistors in here, so we're going to add all of them up. We're going to get 124 ohms of resistance, and this is for our I2. Our 26 ohms and our 90 ohms are in opposition from our I1 and I3, so we have to subtract these. Now we're going to look at our I3. So we have all these resistors, and we're going to add them together. We're going to get 125 ohms. This is for our I3. We know that our 5 ohm resistor and our 90 ohm resistor are right next to our I3 and, our I2 and I1, and these are in opposite directions, so we're going to have to subtract these again. And now we get these equations. So I'm going to rewrite them so the I1s are all in this column, I2s are in this column, I3s in this column, and our constants are going to be in this column. We can see that all of our I1s are together, all of our I2s are also together, and our I3s are also together, as well as the constants on this side. I'm going to use a matrix calculator because this is pretty long, and although we can do it by hand, it's more time efficient to just plug it into a matrix calculator. I'm going to use one by Symbolab. You can just Google that, or I'll have that link below. And to make this simpler before I plug it in, I'm going to have our I1s be an X, our I2s be a Y, and our I3s be represented as a Z. I plugged all of these into our calculator right here, click go, and it gave us our solution. So we know our x's is 5, z is 2, and our y is 5 over 2. We can change these back into our I1s. So we know that our x is I1, or I1 is equal to 5. Our I2 is our y, so our I2 is equal to 5 over 2. And lastly, our I3 is z, and that is just 2. Looking at this, we want to find the power of our 80 volts. We're going to do that over here. So we're going to set power equal to, well, there's a couple of different ways we could find power. I'm going to write the different formulas down here. We have power is equal to voltage times current. We also have power is equal to current squared times resistance. And we have another one, but these are the only ones that we're going to look at for this part right here. For the 80 volt power, we know that we have voltage. We have this 80 volts right here. So we know that we are going to use the first formula. So plugging this in, we're going to have 80 volts. This is being multiplied by the current going through here. Well, the only current going through here is our I1. So we're just multiplying this by 5 amps. And this is going to give us the 400 watt power for our P80 volts. Next, we're going to look at the power for our 8 ohm resistor. We don't have voltage in here, so we're going to use the other formula where we have our current squared times resistance. The only current going through our 8 ohm resistor is the I over 2, which is our second resistance. Remember, if it's up against something, so if we were finding the resistance for, if we were finding the power for this 90 ohm resistor, or this 5 ohm resistor, or this 26 ohm resistor, we would have to compensate the fact that there's current going in the opposite direction. We would find this I1 and then subtract the I2 going into it. But since we don't have that for our 8 ohm resistor, we're just simply going to have our I2 squared, like normal, times our resistance, which is 8 ohms, and this is also amps squared, and that's coming from this part right here, should be amps squared. But if we do this, we are going to get that our power for our 8 ohm resistor is equal to 50 watts. I did make a mistake for our first part though. I forgot that our current is going, and I'm going to do this in blue because it's important, our current is going this way, right? We noted that. And we also noted that our voltage is going this way. However, I totally forgot that since they're going in opposite directions, that means, like we stated earlier, there is going to be a negative out front, like we wrote right here, this negative. So we should have a negative 80 volts, meaning we're going to have a negative 400 watts. That's super important because if our power is positive, that means it's being absorbed, like for part B. If it's delivered, that means we're going to have a negative. So that's super important to look out for. And that is how you do this problem.